Hello everyone, today I'm going to teach you how to do this spinning in, scaling up UI animation in Unity. So let's get started. If you just want to copy and paste the script, I'm just going to tell you everything you need to know to do that and to get it set up and running, and then you can just copy and paste it and get going. Won't waste any more of your time, but if you do care a little bit more about how the script works, we'll go over that afterwards as well. So let's start off. So I'm not going to tell you exactly how to set up your scene in Unity, but you obviously need a canvas and some UI elements, right? So have your UI element that you want to scale and fade in, do the animation on. Make sure that that is set to inactive, so untick this so that it's prepared to be turned on and animated in. But just have a look at it. That's what mine looks like. Yeah, it doesn't matter what size it is or anything. Just make sure that it has that script on. So I've called it rotate and scale UI animation. Make sure that the code is pasted in there, and you should see one variable here called duration, and that's just going to be in seconds how long you want the animation to be. Mine is set to 1. You can change that to whatever you want. And then you're going to have a couple of buttons, one for open, one for close. You don't need to do both of these things off of a button. You can do it off of a bit of code. It can be triggered when a player goes into a certain collider or something like that, or it could be wherever you want. But for now, I've just set it to be on these two buttons. So in the open button, we've got an on-click event that just takes our UI element that we want to animate, and it sets the game object to active. Once the game object is set to active, it does its animation, finishes the animation, we're all good and done. That's all open button needs to do. All that close button needs to do, slightly different, but it takes that game object, so you're going to drag that game object in, and then you're actually going to call a method on that script. So you're going to find that script, which I called rotate and scale UI animation. We're going to find the deactivate method. We're going to click that, and that's all we need. And now when we press play, we're going to see that when we press open, it scales and rotates in, and close scales and rotates out. Okay, so if you just want to copy and paste the code and get going, there you go. That's all you need. If you care a little bit more about how the code works, we're going to look at that now. So I'm going to find that script. It's not too long. There's about 60 lines of code, but we're just going to go over it fairly quickly. But hopefully this will give you a bit of a better understanding of how it works if you need to change anything. So first of all, we've got one variable called duration. I've set this to public. You can set it to private and add that attribute that means that you can edit it in the editor, but I've set it to public and I've set it to 1 second as a default. Then we have a couple of methods. These are the two methods that were called from our buttons. So we'll have a look at the deactivate one first, which was called from our close button. First off, we just have a check to see if the game object is active. So using the active in hierarchy flag of the game object, because if it is already deactive, then we don't want to do our animation again. We're just going to return. Then we're just going to set a couple of variables. We're just going to sort of initialize them. So at the start of deactivating our game object, our local scale should be 1, and our Euler angles, which is the rotation, that should be 0. And that will just start us off in the place that we want to be for our deactivating the game object. So then we start a few coroutines. So rotate, scale, and turn off. These are the ones we're gonna start up, and each of these use the duration variable to decide how long that coroutine is going to be running for. We'll go over those more in detail later, but it's important that you pass in false to rotate and false to scale, because this decides whether it scales up or scales down and whether it rotates clockwise or anti-clockwise. If you want, I guess you could rotate it clockwise when you're deactivating the object and anti-clockwise if you're activating it, so you could swap that to true if you wanted. And then in your on enable method, which is called this method is triggered when a game object is set to active. The reason that we can't do the same thing here, we can't have this as that on disable method and just call game object.setActive false when we want to do the animation, is because if we had that here, we'd start our coroutine of rotating and scaling and doing all the animation, and by the time these coroutines have started, we'll have got to the end of our on disable method and the game object would be disabled, and those coroutines would no longer be running. So if we're doing an animation which is controlled by the game object itself, we can't use the onDisable method. You could have a different game object that is doing the coroutine for you and doing the animation for you. I like it this way. I find it's a bit cleaner. And yeah, you can just call that deactivate method instead of the set active false. Sorry about that, my camera turned off. So on the onEnable method, we are going to make sure that our local scale starts off at 0 and our rotation also starts off at 0. And then we call our rotate and scale coroutines, start them off, passing in true for both. Again, you could have this so rotate is false when we're enabling and true when we're deactivating, and that will just swap the rotations around, but I like it this way. We have our rotate coroutine, so takes in our clockwise Boolean variable. We start off as a start rotation of 0. We have our end rotation depending on the clockwise bool. So all of this is just a simpler way of writing an if statement. This basically means, this question mark means we're depending on this Boolean variable, we're going to set this float to 360 or minus 360. So clockwise, if that's true, we set our end rotation to 360. If clockwise is false, we set our end rotation to minus 360. So if it's going clockwise, we go all the way around clockwise. If it's not, we go all the way back round anti-clockwise, right? Minus 360 or 360. We're going to set our float t to 0, and this is how we're going to keep track of time. And then while t is less than duration, so that's what we set up here, which I've set to 1 second. You can set it to whatever you want. We are going to add time.delta time to t, and then we're going to work out our new z rotation and set that to the Euler angle. Okay, so we're going to do that via this mathf.lerp method. Okay, you don't need to know exactly how this works, but we are passing in our start rotation, our end rotation, and we're doing t over duration. Because it needs to work out how far through the duration are we to, depending on how close the start rotation is to the end rotation. And then we also do modulo 360 of that. That divides it and takes the remainder. That's because we're not going from 0 to 1, we're going from 0 to 360 or minus 360. So we have that modulo here. We don't have the same thing in the scale because we're going to 1 and 0. Hope I've explained that okay. It's a bit confusing, but you don't need to worry too much about it. And then all we're doing is we are taking our Euler angles, which is our rotation, and we're setting that to a new vector 3, and we're passing in 0, 0 as the x and y, because we're not rotating it x or y, we're just rotating it z, and we're passing in our z rotation as it is there. And then we yield return null, which just makes sure that we're not waiting here, because basically what a coroutine does is it allows you to wait for a certain amount of time before something. So if I put this up here, yield return, I need a new, that would say to the program, wait a second before doing any of this. Okay, but we actually already have t and this while loop as our timekeeping, and we're adding time.delta time here, so we just yield return null, and that just makes sure that it goes around the while loop again. And then that will just keep going around the while loop until we've reached the end of our duration, and by that point our start rotation will have gone all the way to the end rotation value. Similarly, we have a scale method, and again we take in a scale up Boolean. Our start scale depends on the scale up Boolean. If scaling up, then our start scale starts at 0. If scaling down, then our start scale starts at 1. And then the other way around for the end scale. If we're scaling up, our end scale is going to be 1. And if we're scaling down, our end scale is going to be 0. Similarly, we set that t to 0. And while t is less than duration, we're going to add time.delta time to t. Do a very similar thing with our mathf.lerp method. The scale at that point in time is going to depend on the start scale, the end scale, t over duration. Then we set our local scale to a new vector 3 scale, and we're passing in scale for each of them because we're going to scale up on x, y, and z. So just make sure that it blows up in all directions. By all means, if you didn't want to scale it up in the x direction and only the y direction, you can change that here. And then we've got our yield return null to make sure it goes back around the loop, and it will keep doing that until the end of the duration, and at that point start scale should be end scale. The only other method we have is just a turn off method, because we just need to make sure that we're turning the game object off. Obviously we only do this when we're deactivating the game object. So we start the coroutine at the same time as rotate and scale, and because we're using the same duration variable, we're going to wait for the same amount of time it takes to do both animations. As I said before, yield return new wait for seconds duration, that's going to wait for how long the duration is, and then it will set the game object to inactive. And that is it. That's how the script works. Hopefully I've explained that okay. Like I said, the mathf.lerp is a bit confusing, and to be honest, I'm not sure I fully understand exactly what it's doing, but you don't need to be able to use the code or tweak it to what you want it to do. Yeah, I hope that helped you out. Let me know if you have any questions or if I've got anything wrong. But I think this is a nice little 60-line script that you can just, the main thing is that you can just copy and paste it, and you can put it on any game object you want. And just by setting it to active or calling the script's deactivate method, we can have those nice animations. And from now on, whatever UI element you want to add, as long as you put that script on, you can have this animation for free and you don't need to do any extra bit of code. So yeah, I hope that helped you. Follow me for more, leave me a like and a comment and a subscribe and all that good stuff, and I love you very much, and goodbye.